Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and in previous videos I have explained binomial distribution, Poisson distribution and discrete uniform distribution. Now I am going to explain you one of the important discrete distribution in which events are dependent, and we will see that how it is different from binomial distribution. So without further delay, let us see. So in previous sections we studied distributions such as binomial distribution, as I have explained you, and see that the binomial distribution that assumes that each trial that is independent and the probability of success remains constant. This is the 2 point you should understand. Each trial is independent and probability of success that remains constant. Now after this, see that here, however in many real life situations selections are made without replacement. So that means samples are not replaced back in, you can say that, again. So in that situation, in such cases the trials are not independent and the hypergeometric distribution is used. So we will use hypergeometric distribution when trials are not independent, that means they are dependent. And let us take an example. So suppose we have 10 tickets numbered from 1 to 10 and we draw 3 tickets without replacement. What does it mean? Means we have 10 tickets and we are taking 3 tickets, but we are not replacing it back in the pool of 7 tickets. So what will happen in this scenario? The events are dependent, and let success be the event of drawing and odd numbered list. So total odd numbers 1, 3, 5, 7 and 9. And if we replace the ticket each time, the trials are independent. What we do in Bernoulli distribution and binomial distribution, and we use the binomial distribution here, basically binomial. And if you do not replace the tickets, the trials are dependent and we use the hypergeometric distribution. Remember, if we do not replace the tickets, that means events are dependent, and in this case we will use hypergeometric distribution. So the hypergeometric distribution that gives the probability of obtaining exactly x successes in n draws. And from a finite population of size n containing m successes, and thereafter total population is n and there are m successes, so that means there are n minus m failures. And see that here, when sampling is done without replacements, we will have m x, n minus m, n minus x, and n. That is the success and that is the failures. Now let us see, and what is n? Total number of trials, total number of items in the population, thereafter m, number of success items in the population, and small n, number of draws, how many samples you are drawing. Thereafter x, number of observed successes in the sample. So these four are very important. And what is the mean? In previous videos I have again explained expected value of x. So you will multiply x by frequency probability mass function, and you will just sum over and you will get. The same way you can get here, and I am leaving upon you that you will do. And variance you can also calculate. And here the term n, capital N minus small n upon n minus n, that is the finite population correction factor. And you will see this formula when you are doing sampling without replacement in other cases too. And let us see ticket problem. 10 tickets are numbered from 1 to 0, 1 to 10. So 5 tickets have odd numbers and 5 have even numbers. So failures means even numbers are failures and the odd numbers are success. So 3 tickets are drawn without replacement. And you can calculate here that 5 out of 5 we are selecting 2, and 5 from other 5 1, and the total are 3. So that would be equal to 10 into 5 upon 120. So if we find that the probability that exactly 2 tickets have odd numbers, so this one is the success portion and this one is the failures. So that is g n minus m, and that is g small n minus x. So that is 1 and that is 2. So probability would be 0.4167. Let us see another example. So a jury of 12 members is chosen from a pool of 20 people, remember. And 8 are men successes and 12 are women failures. It is means denoted. So find the probability that the jury contains exactly 5 men. So here you can say that 12 are selected. So 5, that is success, m, here x, here n minus m, here failures are women, and 20 means total n, and here n, small n. So this is the probability we are calculating here. So let us see what would be the probability. So that was the probability you can calculate. Now let us see another one, fish tank problem. So a tank contains 200 fish, 60 are tagged and 140 are untagged. This is the problem we will solve. A sample of 10 fish, here see that 10 fish, that is means small n, is drawn without replacement. So without replacement means we will use hypergeometric distribution. If it is with replacement, so we can use binomial distribution. So 60, here 40 total successes, and this part is failure. This part is, you can say that success, and this one is failure. And you will divide by the 200 Cn here. Cn here n is equal to 10. So this is the probability for x, 4 successes here. Let us see third example, a lot of 25 units. You can think lot as a container. and 10 are defective units. So an engineer inspects 2 randomly selected units from the lot. He inspected and the lot is accepted if both selected units are non-defective. Remember. So see that here. So we are to find the probability that the lot is accepted without further inspection. That means, see that how will you calculate probability here? So n is 25 defective units, 10 sample size, n is equal to 2. This is drawn. Now, so no defective units in sample, so that part basically 10 here, 10 C0 there would be successful one, and that would be 15 into 15 C2, and this is 25 2, right? So that means here probability of no defective units in a sample you can get after calculating this one. So finally you will get 0.35. So let us see important properties. So in hypergeometric distribution, trials are dependent since sampling is without replacement. Remember, sampling is without replacement. That means that you are taking sample but not replacing it back into the pool or population. The total population n is finite, it must not be infinite, and the random variable x can take integer values, that is the, you can say that, bound on x, and the sum of all probabilities is 1. This is not new thing, you already know. If we compare it with binomial distribution, so binomial distribution assumes independent trials with constant probability, and the hypergeometric distribution assumes dependent trials without replacements. This is the major difference. If you want to understand hypergeometric distribution, so this is the major difference. Trials are dependent in binomial distribution, and hypergeometric distribution trials are dependent. When n is large and n is small, the hypergeometric distribution approximates the binomial distribution. That can be approximated to binomial distribution. When n is very large, population size is very large and sample size is very small. Summary is here. When to use? Used when sampling is done without replacement. So you will use hypergeometric distribution when sampling is done without replacement. And suitable for a finite population, not infinite. And there are 3 parameters, n, m and n. And probability formula m, x, and this is for success. Again I am drawing success 1 and failure 1. And that is the total ways. This is a success ways, failures ways and total ways. So this way we calculate the probability. So here we will also calculate. So this is the PMF, probability mass function of hypergeometric distribution. Mean and variance summarize the distribution's behavior. You will calculate because many times I have calculated the same thing. So hope you understood, and you will support my, you can say that, website, YouTube channel, handle is PostNetwork Academy, Facebook page, LinkedIn page, and if you need some code, you can also reach GitHub repository. So hope you have understood. Thanks for watching the video.